I think it needs more, don't you? It needs to go more in that direction with an arrow. It needs to go more in this direction with an arrow, right? Okay? Now, that's one way to graph this problem. But I want to show you an easier way to graph this problem. There's an easier way. If the problem says y equals, then there's no better way to graph the line than to find the y-intercept and the slope. But if you'll turn to page 251 in the one-step book, this is the third edition of the Basic Algebra one-step, page 251, and I'm going to continue with this as my example. I'm going to show you an easier way to graph this that you won't have to go through all this trouble. Now, if you like doing it this way, you can keep on doing it this way. This will most always work. I think there might be a couple of cases where it doesn't work by this method. But you can most always do the problem by this method. But there is an easier way. Let me show you how this is. Let's go back to the equation. Negative 2x plus 3y equals 12. This is going to amaze you. It's going to be so simple. You know it's a straight line, don't you? Just because it's in this section. We wouldn't do this to you in basic algebra. We wouldn't give you an equation that's not a straight line. What do you think we are? Mean math teachers or something? No. There are always going to be straight lines in basic algebra. Until at least next week. And then I'll show you what's not a straight line, and maybe you'll be able to pick those out. But for now, it's a straight line. So how many points does it take to graph a straight line? 2 points. Now, so let's go back to our make a table of values attitude and pick a value for x. Pick a value for x. What would be the easiest value to pick for x equals 0. Boy, I'm glad you're with me on that one. Now, if x equals 0, what are we going to do? We're going to put 0 back into this equation for x. Okay? And what will you have if you let x equal 0? What will this say now? Negative 2 times 0 is 0. What would you have altogether? You'd have 3y equals to 12. Now, what would y have to be? 4, okay? Y equals 4, because 3y equals 4, we just divide both sides by 3, and you'll get y equals 4. Do you see that? Now that's an easy point, wasn't it? Isn't that easy? You know what? If that was so easy to let x equal 0, why don't we let y equal 0 to get the other point? Wouldn't that be just as easy? In other words, if the 0 point for x is so easy, let's use 0 point for y. Let's let y equal 0. Do you see what I'm going to do now? I'm going to take this value of y, I'm going to take that 0 out of there for x. Now x is back to x. Okay? Now I go back to that original problem and I put in a 0 in place of the y. Alright? And now what would the equation have left in it? Negative 2x. Can I write that down right here? Negative 2x, right? And then what? Plus 0 equals 12, right? Equals 12. So now what does x equal? Divide both sides by negative 2, and you'll get x equals negative 6. So you get 0, 4, which is called the y-intercept, because you see that's where x equals 0, y equals 4. Do you see that? 0, 4. And then if we let y equal 0 and find x, that's going to be called the x-intercept. And those are the two easiest points to graph. And now let me graph this. Graphing these 2 points, what do I get? 0 and up 4. 0 and go up 4. 1, 2, 3, 4, like that. And then I'm going to graph negative 6 and 0. Negative 6 and 0. Now that means go negative. Now what does this negative 6 represent?
Down 6.
Now, whoa, wait. What does the negative 6 represent? It's in the x column, doesn't it?
Yes.
It means x is negative 6. So where are we going to go with negative 6? To the left. 6 6.
On the X line.
On the X line, negative 6. To the left on the X line, 1, 2, 3, 4, 5, 6. Okay? Like that. Any questions on that? Okay, now I got these 2 points. Now what do I need to draw the graph? The line. All I have to do is just draw the line between those 2 points. Alright? Now, I want you to compare this problem with the one I did over here. How do the graphs compare? It was the same equation, wasn't it? It was graphed with a different method, but it's the same line. It's the same line. Any questions on that? Do you see how that works? Now, which way is easier to graph a line? If it's written in the form like this, if it's written in a form with x's and y's equals a number, would it be easier to solve for y, find the slope and the y-intercept, and then graph with the slope and the y-intercept? Or would it be easier to get the x and the y-intercepts? Okay? I think this is going to be easier. So when you get to the problems on page 251, 252, and 253, that's what I want you to look at. All right? So that's all I think. Well, let me do one more example. Let me do one more example. In the meantime, could somebody pass around a piece of paper to sign? Sign a piece of paper before you leave. Okay? I want to take attendance on this class. All right? Let me do another example of this type. I think I have a couple more minutes left before we completely run out of time. So I would like to take problem number 18 on page 252. Page 252. Oh, I forgot to write down the problem. 2x minus 3y equals to 12. Okay? Now, what do I do first? Because it's in the form of x's and y's equals a number, I want to be sure to get a table of values and start off with x equals 0. Now, if x equals 0, then what would you have for y? Put in 0 in the place of the x. 0 in place of the x, and what do you have? 2 times 0 is 0. Okay, we can just forget about it. We don't have to write down 0. Then you'll have what? Negative 3y equals to 12. So what does y equal? Divide both sides by negative 3, which would be y equals... Divide by negative 3, and you get y equals negative 4. Okay? Negative 4. So I get the point 0, negative 4. Now, what next do I need? All right, let's let y equal 0. Let's let y equal 0. Now, let me go ahead with this. Now, if you let y equal 0, now we're going to put x back. Yes, that's right. We're going to put x back in there. And now we're going to let y be 0. So we're going to put 0 in place of the y, and you'll have this instead. You'll have this equation comes down here like this and says 2x what? Minus 0, can I just put 0? Equals to 12, right? And then what? You're going to have to divide by 2, aren't you? Divide by 2. So what would that give you?
6.
X equals 6. Okay, so that's going to give you x equals 6. Okay, change colors here. X equals 6. So x equals 6. All right, now graph the 2 points. Graph the 2 points. Let's see what we've got. X and y, and I need to graph these 2 separate points. Now, we're not doing slope now, are we? We're not even dealing with slope. All we're doing is graphing 2 points. But actually, these are the 2 most important points in the world anyway. The y-intercept, which is what? 0, negative 4. So how do we graph 0 and negative 4? Go down 4. And there's the first point. And then 6, 0. How do we graph 6, 0? What does the 6 represent? X. See, 6 is x. Which way do we go with x? To the right or to the left? How do we know which way? It's positive, so we go to the right.
Depends on the sign.
Depends on the sign. If it's negative, we go to the left. If it's positive, we go to the right. So we go over 6. 1, 2, 3, 4, 5, 6. And there is this point would be called what? What do we call that point? That special point where it crosses the x-axis is the x-intercept, right? What's this point called? Y-intercept, okay? And what do we do to get the graph of these 2 points? Draw a line between them. You know, just like you did back in 3rd grade, dot to dot. Just connect the dots. Only you don't just connect the dots. If I just connected the dots, I'd have that, right? And I'm not going to be happy if I see that, because that makes me think you don't know it goes on forever, right? It goes on forever that way, goes on forever this way. Okay? Now I've got 2 cautions, and then we're finished. The first caution is when you do this, you be very, very careful with your signs. When you get the x and the y-intercepts, you be particular about these signs, because if you miss a sign, your graph is not even going to be close. Your graph, instead of going off this way, your graph's going to be going this way. You're not even going to be close. Your graph is going to be so far off, you'll wonder what in the world happened. So be very careful of your signs. And another thing is when you start looking at this in your homework, if you took notes on this problem and you look at the homework, what's the first? You do the homework probably in black and white, right? I do it in color up here, but you're going to probably be doing it black and white. When you get home, one of the first 2 things you're going to look at when you see this little table of values, you're going to see 0, -4, and then what are you going to see next? 6. And you know what you're going to wonder? Where did I get 6? Aren't you? So what you're going to have to remember is we didn't go 0, -4, and then 6, 0. What we did, we started with 0 here, and then we found the -4. And then we turned it around, and we started with 0 over here. And after the 0 here, that's where we get the 6. We didn't start with 6 and get 0. We started with 0 and got 6. So do something to emphasize that. Maybe what you could do is emphasize this in this way, to say, hey folks, this is where we started, and this is where we started. And do something to make that point clear to yourself, so you won't come down here and wonder, where did he get the 6? Okay? Any questions on that? Yes?
Will there ever be a time when it equals like a 7 or
oh, something that doesn't come out even?
Yeah.
It sure will. Like probably in intermediate algebra.
Okay.
Yeah, I think in basic algebra we try to build your confidence by making it come out even. But you know, what if it? As long as you ask the question. What if it does equal, let's say, 10? Then what would you have? Let's do a problem like that, where it doesn't come out even. And I want to dispel another myth. A myth that I sometimes have in my classes is that everything comes out even. So if I do something like this, make a table of values, and you let x equals 0, then what would y have to be?
3.3.
Negative, don't forget the negative. See what I said about the negatives? I caught you on the negative already. Negative 10/3, which is -3 1/3. And is it okay to graph a fractional value? Yes. -3 1/3. You know, a third of the way between -3 and -4. You can graph a fraction. That's what you'd have to do. Okay? Only I won't finish it right now.